Welcome back to this lecture on rules of inference. In this second segment, we will introduce 3 new rules of inference, and we will also discuss 2 counterexamples. Our first new rule of inference is called addition. It only has one premise, P, and it allows you to infer from P the proposition P or Q. I will let you prove the validity of this inference rule using the truth table algorithm. But intuitively, the reason this rule of inference works is because if we assume that P is true, we already know that true or anything is also true. Now this rule is called addition because you can start with any proposition whatsoever. Remember, this is a template. And from that proposition, you can always infer a new proposition that you obtain by adding a disjunction connective and therefore building a disjunction between the original proposition you knew which was true and any other proposition whatsoever, Q. So this rule of inference is called addition. Please keep in mind that in the rule of inference called addition, what we are adding is an OR connective. I will let you think about whether adding a AND connective would also produce a valid inference rule. But for now, let's consider our second new inference rule. It's called simplification. It also has one premise, namely P and Q. And it says that from any conjunction P and Q, you can infer the proposition P. Intuitively, this rule makes sense because if the conjunction is true, the only way for a conjunction to be true is that for both of its operands to be true. In other words, P in particular must also be true. I will let you prove that using a truth table again. And as a last comment on simplification, notice that you could also infer Q from P and Q. But by definition, the rule of inference called simplification allows you to infer the first operand of the conjunction, not the second one. Now let's consider our third and last new rule of inference for this segment. It's called conjunction. This rule of inference has 2 premises, P and Q, and it allows you to infer their conjunction, namely P and Q. It's pretty easy, but I trust you'll be able to prove the validity of this rule of inference using a truth table. But really, this rule of inference follows automatically from the definition of conjunction. Namely, if you assume that P is true and you also assume that Q is true, then clearly the conjunction of the two is also true. So notice the name of this rule of inference is very intuitive since it's named after the kind of proposition that you can infer with it, a conjunction. In contrast, the simplification rule also applies to a conjunction. So I will let you think on your own whether this rule would also work if the conjunction was replaced with a disjunction. In other words, if the premise is P or Q, are you allowed to infer P? Is P a logical consequence of a disjunction P or Q when P and Q are any propositions whatsoever? Now that we know both the name and the template for 3 new rules of inference, let's turn our attention to a different kind of reasoning called fallacies. A fallacy is basically an invalid argument. It's almost the opposite of an inference rule. It's something you should never do. So for example, let's say you start with a conditional P implies Q, the same way you would start with in a modus ponens or modus tollens. So you assume P implies Q is true, and then you also happen to know that Q is true. The question is, are you allowed to infer from these 2 premises that P then must be true? Well, the answer is no. And the mistake you made here, if you follow this reasoning, is to assume a conditional and then to assume that its conclusion is true, as opposed to its premise, as you would do in modus opponents. So the name of this fallacy, which means this invalid reasoning, is the fallacy of affirming the conclusion. Notice one way to make this fallacy into a rule of inference is to swap the order of P and Q. In other words, instead of using P implies Q, if you had the converse, namely Q implies P, then you would be assuming the premise of that conditional and you would be basically using the modus ponens. So make sure to remember this fallacy and to never use it in an argument or proof. Let me point out a second form of invalid reasoning or fallacy, which goes like this. Start with the same conditional, P implies Q. Assume that's true, and then assume that not P is also true. This reasoning would then infer that not Q must be true. So this fallacy says, if P implies Q, and you know that P is false, then you can infer that Q is false. I will let you use a truth table to show that this reasoning is not valid. And by the way, you could have done the same for this fallacy. Now the name of this fallacy, which is again an invalid form of reasoning that you should never use, is the fallacy of denying the hypothesis. Because the mistake you would make here is to assume that if a conditional is true and then you deny its hypothesis, namely you assume the negation of its hypothesis, then you are allowed to infer the negation of its conclusion. Please make sure to learn these 3 new rules of inference, as well as and to avoid these 2 fallacies in the rest of this course.